Hey, honors chem students, Mr. Lambert here. I was thinking about this. I wanted to preface this video with some issues that I had yesterday. I spent over an hour making a 12-minute video for my physical science students because I was trying to make it as perfect as can be, and I realized that that's just not going to happen and it takes too much time. So if I mess up, I mess up. These videos are being published on YouTube for you, the Conval students, and even though the world can see them, um, I hope they don't because they're meant for you. So anyway, this is going to be the start of lesson 9, chapter 9. We are going to be talking about the law of conservation of mass. I'm trying to do this up in the corner so all the students can refer back to this. We're in lesson 9. It is chapter 9 of your textbook. It's section 9.1, and it covers pages 250 to 252, and it is the conservation of mass. The law of conservation of mass, it's in your book, says explicitly the total mass of the reactants in any chemical reaction has to equal the total mass of the products. Mass has to be conserved. You can't create mass, you can't destroy mass in any normal chemical reaction. So let's take a look at an example problem from the book. So here is sample problem 9.1 on page 251. It describes, let me get my marker here, it describes the combustion of methane gas, CH4. Of course, with a combustion reaction, you need oxygen. There's some sort of chemical change here. And the product side is going to be carbon dioxide gas and water vapor. Notice that the equation given to you is already balanced. The mole to mole ratio is a 1 to 2 to 1 to 2. Keep in mind we don't put coefficient ones in front. The symbol or the chemical formula alone tells us that we have one of those, one unit of those. So the problem is asking what is the total mass on the reactant side and the product side. So we have 4 chemicals here. Note that. The first one is going to be methane gas. Let me refer to the book here to save myself a little bit of time. We have CH4, and if you add up the molar masses of each element and you find the molar mass of this chemical, it's going to be 16.04 grams. 16.04 grams. That's the molar mass of CH4. Then we're going to add 2 moles of oxygen gas. Keep in mind that oxygen gas is written as O2. We simply have 2 molecules, 2 moles of it. There's a coefficient of 2 in front of it. So we have a total of 4 oxygens, 4 oxygen atoms, 4 moles of oxygen. Each oxygen on your periodic table has a molar mass of 16 grams per mole. We've got 4 of these things, so we're going to have it. We're going to have the molar mass of 64.00 grams. So on the reactant side, 16.04 grams worth of methane plus 64 grams worth of oxygen gas. Let's go to the product side. So on the product side, we have 1 molecule, you could say 1 mole, 1 unit of CO2. If we had 1 mole of CO2, that's going to have a molar mass, if you add it up, of 44.01 grams. I'm going to put a line right here because this is the reactant side and this is the product side. And we also have, if you think about it, 2 moles or 2 molecules of water. I'm going to say 2 moles because it's going to be in grams. So if each mole of water has a mass, add up water. I'll try to block this out. Each mole of water weighs 18.02. Your textbook has 2 moles of water having a mass of 36.03. It could be 36.04, but in this case, your textbook has it as 36.03 grams. So in this balanced chemical reaction, what's happening with the mass of the reactants versus the products. If you add up 16.04 plus 64 grams, you're going to get a mass of 80.04 grams of reactants on the left side. And what happens if you add up the product side? If you do, you'll get the exact same number, 80.04 grams of products. Notice that mass is conserved. I'm going to do one more problem with you on this video. It's going to be on page 252, problem 9.2, and I'll lay that out for you. I wanted to do an even problem so that you didn't have the answer and we could talk about it together. So here is problem 9.2. It's part A. There are two problems, but we're just going to do the first one together. Notice that we have a balanced equation here. We have 2 aluminum units, or 2 moles of aluminum, we could say, plus 3 moles of chlorine gas will yield 2 moles of aluminum chloride. The mole to mole ratio is a 2 to 3 to 2. Those are going to be important when we calculate the mass. So the problem is asking, calculate the total mass of the reactants and the products. I wanted to just go through this with you so that you can follow my lead in doing any of these problems in the future. First off, we have 2 moles of aluminum. So I've got my periodic table right in front of me, and I'm going to look at aluminum element number 13. 26.98 is what each mole of aluminum, 26.98 grams is what each mole of aluminum has for a mass, but we're going to multiply that by 2 because there's the coefficient of 2 in front. So 26.98. Take my phone. Again, I wanted you to see me do this so that you can follow my lead. 26.98. Nope, not 26.98. 26.98 times 2 will give us 53.96 grams right here for aluminum. 53.96 grams. Let's look at our chlorine gas. Notice that each mole of Cl2, each mole of chlorine is a diatomic molecule, Cl2. We've got 3 of them. So multiply that across, distribute the 3 with the 2, and we have 6 total chlorines. So we need to look at our periodic table, look at the fact that chlorine is 35.45, multiply that by 6. So 35.45 times 6 will give us 212.7 grams. And again, this is plus right here. 212.7 grams of chlorine. So this is the total mass of our reactants. Let's add that up. I'm going to take my 212.7. I'm going to add plus 53.96. I screwed that up. 53.96 equals 266.6. 266.6 grams. That is the reactant side. Let's take a look at our product side. We have aluminum chloride. And so keep in mind, because it's a balanced equation, we have a total of 2 aluminums and 6 chlorines. So if we take let's look at this chemical, the aluminum chloride, and find the molar mass of it. You can easily look that up on Google. I expect you all to know how to find molar mass by now. But let's look up the molar mass of aluminum chloride, AlCl3. I did look it up on Google because it's going to give you a slightly different number than this, but let's keep in mind that if you have 2 moles of aluminum chloride, you're going to have a total of 6 moles of chlorine and 2 moles of aluminum. So it should match. 2 moles of aluminum is going to have a molar mass of 53.96, and then you've got your chlorines, which will have a mass of 212.7. If you want to see what it looks like with just the molar mass of aluminum chloride, I'll do that, and I'll do that now. According to Google, the mass of a mole of aluminum chloride, and I just looked it up, has a molar mass of 133.34, and that's from Google. It's not going to be quite the same because of different amounts of sig figs and different periodic tables. But basically, if you take this and you multiply it by 2, you're going to have the same mass that you had from your reactant side. In any chemical equation, the total mass of the reactants is going to equal the total mass of the products.